Good morning students, HS second year mathematics, and we are doing application of derivative, that is chapter 6. Already we have done some sum of course exercise 6.1. So now we'll start. As we have finished up to question number 14, so we will do from question number 15. Question number 15 is like that: the total cost Cx in rupees associated with the production of X units of an item is given by Cx is equal to 0.007 x cube minus 0.003 x square plus 15x plus 4000. Find the marginal cost when X is equal to 17 units are produced. So let's start. It is our exercise 6.1 and question is what? 15. Cx, it is given as 0.007 x cube minus 0.003 x square plus 15x plus 4000. It is given what? Cost price. They have asked to find marginal cost. So marginal cost, if you want to find, then what to do? You have to differentiate C, that is cost of production, with respect to X. So if we differentiate D Cx with respect to X, it will be, this is constant 0.007 into 3x square. So this is the rule, that if you want to find the marginal cost, what to do? You have to differentiate the cost price, and that will be the marginal cost. Then this one 0.003 into twice x. If we differentiate x square, if we differentiate x, it is 1500. So this is your marginal cost. Simple thing. So you have to we have that knowledge only, that differentiation of cost price is marginal cost. Now at x equal to 17, if we put x equal to 17 here, 0.07 into 3 into 17 square minus 0.06 into 17 plus 50. Then after simplification, we will get 20.967. Calculation I have skipped. Already I have calculated earlier to save the time. So this is our what? The marginal cost, and that we can calculate from our cost price. Now we will go for question number 16. Question number 16 is like that: the total revenue in rupees received from the sale of X units of a product is given by Rx equal to this. Total revenue. Find the marginal revenue. This time also same thing, that Rx is given as 13x square plus 26x plus 15. This is our revenue. So here also, if you want to find the marginal cost, same thing you have to do. What to do? You have to differentiate this one, Rx revenue with respect to X, and it is 13. This constant will come out. X square differentiation is twice X. Then 26. If we differentiate X, it will be 1 and 15 to 0. Now when X is 7, then it will be, so required marginal cost will be 26 into 7 plus 26, and after calculation, as I have calculated earlier, 208. So required marginal cost when X is 7, it is what? 208. So again here, what? Revenue we have differentiated to get our marginal revenue. Now question number 17. question number 17. It is like that. The rate of change of area of a circle with respect to its radius r at r is equal to 6 centimeter is 10 pi, 12 pi, 8 pi, 11 pi. So rate of change of area of a circle. So here you see that we know area of a circle is what? Pi r square. So we have to write, we know area of circle, if I give a symbol A, then it is pi r square. Area of circle formula is what? Pi r square. We have to find what? Rate of change of area of a circle with respect to radius r. Here r is radius. So if we differentiate dA with respect to r, then it is pi, and r square differentiation with respect to r is twice r. So twice pi. First sum, they have said what? It is r is given as 6. So if we put 6, it will be what? 12 pi. Of course, its unit will be centimeter. Now see, out of these so many options, we found what? Option B, that is 12 pi, is our correct answer. So answer is what? B, that is 12 pi. So this is our question number 17. Now we will move for question number 18. The total revenue in rupees received from the sale of X units of a product is given by Rx is equal to 3x square plus 36x plus 5. The marginal revenue we have to find when X is 15. So here also same methods we will use. So question number 18. Here it is given as Rx is 3x square plus 36x plus 5. Then as we have to find marginal revenue, so we have to differentiate this one. Already we know that revenue or cost price, if we differentiate, then we will get what? That marginal one. Now 3 is constant, will come out. X square differentiation is twice x, 36. Differentiation of x is 1. Now 6 into x is given 15. Now 6 15 are 90. 90 plus 36 is 126. So our option D, 126, is correct answer. So with that we end our exercise 6.1. Now we will move for exercise 6.2. Before that, we will gather some knowledge to do the exercise 6.2. Increasing function. Increasing function. F is a function. F is a real valued function. Then F is increasing if x1 less than x2 implies fx1 less than equal to fx2. So if we take x1, x2 from domain, and if x1 is less than x2, and if we find fx1 which is less than equal to fx2, then it is increasing function. F is decreasing if x1 less than x2 implies fx1 greater than equal to fx2. So this is increasing and decreasing. I will show these things with graphs so it will be clear. Suppose it is a x-axis, y-axis Cartesian plane. One curve is like that. Here you see that as x increases, y also increases. So it is increasing function. Now I will show another thing. Here you see that as x increases, y, it decreases. Its value decreases. So this is the difference between increasing and decreasing function. Now we will do little bit modification. Strictly increasing definition we will do strictly. F is a strictly decreasing function if equal to sign we will withdraw. This also strictly decreasing if fx1 greater than fx2. Then graph also will be little bit changed. There and this one strictly and this one there. When x will increase, it will straight increase. And for decreasing, it will straight decrease. No equality is there. I want to repeat this one, that f is a real valued function, suppose on a domain I, and if x1 less than x2, then fx1 less than fx2, not equal to, fx1 less than fx2, then it is strictly increasing. If equal to sign is there, then only increasing. x1 less than x2, if fx1 greater than fx2, then it is strictly decreasing. If equal to sign is there, then it is only decreasing. So that is the difference between increasing and strictly increasing, decreasing and strictly decreasing. Now, one rules are there, because increasing function, decreasing function both at a time we have done. Now, if f dash x greater than 0, then it is increasing and strictly increasing in AB. So I will write that theorem. First one, if first derivative of fx is greater than 0, increasing, it is formula theorem, in what? Closed interval AB, and strictly increasing in open interval AB. So what is the difference? If we get f dash x which is positive, not 0, greater than 0, then f is a what? Strictly increasing in closed interval and strictly increasing in open interval. If f dash x less than 0, then it is fx is decreasing. That formula you have to remember, in open interval AB. AB is what? Domain set, and strictly decreasing in open interval AB. That formula we will use. That is the total thing required for doing this one. So what we have learned, that first derivative, if it is positive, then in closed interval it is increasing, open interval it is strictly increasing. If first derivative is negative, remember here we are not considering 0. Negative means full negative. So not less than equal to or greater than equal to 0. So if f dash dash, that is first derivative, is negative, then fx is decreasing in closed interval and strictly decreasing in open interval. So this is the rules of theorem. Now we will do, with the help of this knowledge, we will do exercise 6.2. Exercise 6.2. Show that the function given by fx equal to thrice x plus 17 is strictly increasing on R. So, what they have given? Fx is given, and it is what? Thrice x plus 17. This is the value of fx. Fx is what? Thrice x plus 1. We have to show it is strictly increasing on real number. Real number is a open set. Real number is an open set, because infinity to infinity now, minus infinity to plus infinity, so it is open set. So only we have to show what? That first derivative is positive. First derivative, if we differentiate with respect to x, this is f dash x. If we differentiate 3x, 3 is constant, x is 1, so 3 is the positive number. So therefore fx is strictly increasing in R. So this is our question number 1. So that we have done. Now we will do question number 2. Show that the function given by fx equal to e to the power twice x is strictly increasing on R. So question number 2, fx is given as e to the power thrice x. Fx is what? E to the power thrice x. Now if we differentiate e to the power thrice x, we have knowledge what? By chain rule we have to do e to the power thrice x differentiation, e to the power thrice x. Then we have to use chain rule, we have to differentiate thrice x differentiation is 3. Now 3 e to the power thrice x. E is what? A term between what? 2 and 3. So its power, anything if you keep, positive, negative, even 0 also, always gives what? A positive term. So 3 into e to the power thrice x is positive. So what we can comment? That this is greater than 0. So according to the rule, it is strictly increasing in R. Why it is strictly increasing, not increasing? Because R is open interval. That's why it is strictly increasing. So that we have done. Now question number 3. Show that the function given by fx equal to sin x is strictly increasing in open interval 0 to 90, strictly decreasing in 90 to 180, neither increasing nor decreasing in 0 to 180. So this is your question. Fx is what given? Sin x. So we write first fx is what? Sin x. Now see the procedure, how to do this type of sum. If we differentiate fx, it will give f dash x. If we differentiate fx, it is f dash x. Sin x differentiation is cos x. Okay, this though all time we are doing. If f dash x is 0, this implies cos x. This is 0. F dash x is the cos x. Cos is 0. Cos, we know cos 90 is what? Our 0. Because cos 0 to 1 and gradually decreasing when it is cos 90, this is. Then we have formula. X is what? Twice n pi plus minus 90. We got this from what? Class 11, we got when cos x equal to cos y, then x equal to twice n pi plus minus y. That thing we have used here, and we will get values now from different value of n. If we put n equal to 0, then it will be what? If so many values will come. So here if we put 0 here, then it is plus minus 90. Other values, if we put suppose 1, twice pi plus minus pi by 2. So it will be what? Twice pi plus, if we give, then it is 5 pi by 2. If minus is there, then it is thrice pi by 2. That's why so many values we will get. Now, what range they have given? First given 0 to 90. If we put values of f dash x in between 0 to 90, then we get what? F dash x 0 is cos 90, so we get this one. Now we little skip, and for x belongs to 0 to 90 we have taken. So if we take any values between 0 to 90, open interval, then cos x is what? Always positive. Suppose in between 0 to 90, if we put what? 30 is in between. Cos 30 is what? Root 3 by 2, a positive term. If we put 45 in between 0 to 90, cos 45 is 1 by root 2 positive, 60, half. So always it is positive. So what we can comment that means implies f dash x is greater than 0 for that interval. So for this, cos x is greater than 0 implies f dash x is positive. So what we can say, therefore fx is strictly increasing in open interval 0 to 90. So we get that values, that if it is positive, then f dash x is what? Like that. So we get first one. Now we will change the boundary. Now we will take 90 to 180 as they have said. Cos 90, suppose if we cos 90, so it is 0. If we take suppose cos 120, then it is a negative term, minus root 3 by 2. Cos 120, how to calculate? We know it is 180 minus 60. It is second quadrant, negative, cos negative, and it will be what? Cos 60. So cos 60 is root 3 by 2. So what we get? Minus root 3 by 2, negative. Not only this, cos 1, that is 35. Then like that, all the values in between 90 and 180, always it is negative. As cos x is negative, so f dash x, that value is negative. So what we can say? Fx is strictly decreasing in 90 to 180. So we get this result that fx is what? Strictly decreasing in this one. So earlier we get 0 to 90, it is strictly increasing. Now 90 to 180, we found it is strictly decreasing. Now you see that x, if we take between 0 to 180, in between 0 to 180 if we consider, then one part 0 to 90, it is strictly increasing, and other part 90 to 180 strictly decreasing, and one portion is there, that is for f90 it is to 0, and that is we cannot say about this one. So here one part increasing, another part decreasing, then we say neither increasing nor decreasing. f dash x greater than 0 for x belongs to 0 to 90, f dash x less than 0 for x belongs to 90 to 180. Therefore, fx is neither increasing nor decreasing in 0 to 180. So this is the answer of this question number 3. Here one part is increasing, another part is not only increasing, strictly increasing, another part is strictly decreasing. So student, that is the thing, that when we have to calculate increasing means for the value of x when increases, if fx is also increases, it is increasing. If it is open interval, then it is strictly increasing. If closed interval, only increasing. If x increases, fx decreases in open interval, then it is decreasing, strictly decreasing. If what it is in the if we take what equal to sign, fx1 greater than equal to fx2, then it is only decreasing. Theorem said f dash x, if it is positive, then it is strictly decreasing, strictly increasing what in open interval, and only increasing for closed interval. If f dash x is negative, then fx is decreasing in closed interval, and f dash x, if it is negative, then it is strictly decreasing in open interval. So with that formula we have done, and we have done up to question number 3. So student, I hope that you understood these things. If you have problem, you can ask me over telephone also. You can send WhatsApp in my personal mobile group, though you cannot send. So with that we end our today's class.